Alright, probability, day one. So, Friday, not here obviously. Watch the video, take notes, work on the homework, work with each other. Day one should be a lot of review stuff. I can statements. I can determine probability in experimental and theoretical situations. Can determine the complement of an event and find its probability. And I can find the probability of two events, both independent and dependent. So, first things first, probability, what is it? Probability of an event happening is equal to the number of ways it can happen over the total number of outcomes. So, P of A, or the probability of anything happening, is equal to the number of ways it can happen over the total number of outcomes. Probabilities can range from 0 to 1 if we're talking about fractions or decimals. Can range from 0% to 100% if we're talking about percents. Right? A lot of times we'll use fractions, sometimes we'll use percentages. We can switch in between both, not a big deal. Right? But 0 to 1 for fractions and decimals, 0 to 100 for percents. It's just scale on here. So if it's at 0, whether it's a 0 for fractions or decimals, 0 for percents, that's basically impossible. If it is 0, it is impossible. It'll never happen. If it's 1, it is certain to happen. If it's 100%, it is certain to happen. Closer to 1 you get, the more likely it is. Closer to 0 you are, the more unlikely it is. Pretty simple. Couple definitions. Probability does not tell us exactly what will happen, it's just a guide. So we toss a coin 100 times, how many heads will come up? Well, probability says there's a 1/2 chance that we'll get a head. So we would expect 50 heads. Obviously, every time that's not going to happen. Right? That's why there's a difference between experimental, theoretical, all that sort of stuff. So, an experiment or a trial. It's an action where the result is uncertain. So it's anything you do. Right? It's rolling a die. It's picking a card. It could be flipping a coin, right? It's any of those things that we do where we're not sure what's going to happen. An outcome, so it's a possible result of that experiment or the trial. So if I'm rolling a die, an outcome would be rolling a 2 or rolling a 4. It's one of the possible things that can come from our experiment or our trial. Lastly, the sample space would be all the possible outcomes. So in my experiment or in my trial, all the possible outcomes, if I'm still talking about rolling a die, all my possible outcomes would be that I could roll a 1, 2, 3, 4, 5, 6. So that would be my sample space. Be anything I could get from my experiment or my trial. Alright, two different types of probability we're going to talk about right now. Theoretical probability and experimental. Theoretical is we're using math to find it. We use math to find our answer. It tells us what's supposed to happen in theory. Right? Flipping a coin 100 times, we should get 50 heads and 50 tails because there's a 50% chance of each. Now, that doesn't necessarily happen, but theoretically, that is what should happen. Experimental probability. Probability based on data collected. So we flipped the coin 100 times. It's a probability of what happened when we flipped it 100 times. So we actually perform the experiment. It doesn't always match the theoretical probability, but if you keep performing it enough, like 100 flips of the coin is not enough. 1,000,000 flips of the coin, we're getting closer and closer. The more times we do something, the more the experimental probability gets closer to our theoretical probability. So, he said if we perform it 1 billion times, or even more than 1 billion, billions, we should get very close to achieving our theoretical probability. So remember, theoretical, what's supposed to happen. Experimental is what actually happened. Complementary events. The complement of an event are all outcomes that are not the event. So when the event is a heads, the complement would be a tails. When the event is Monday or Wednesday, the complement would be Tuesday, Thursday, Friday, Saturday, Sunday. When the event is a heart, the complement would be a spade, a club, a diamond, or a joker. Right? If the event was rolling a 1 on a die, the complement would be rolling a 2, 3, 4, 5, or 6. Anything that's not what we want would be our complement. So, an event and its complement represent the complete set of possible outcomes. So anytime I add an event and not the event, or I add the event and the complement, it should equal up to 1 if I'm talking about fractions or decimals. It should equal up to 100 if I'm talking about percentages. So anytime we have the event plus the complement should equal 1, Vice versa, if I want to find the complement of the event, I take 1 minus that event that I'm talking about. Sheesh. All right. So, we said examples, rolling a 3, then not rolling a 3, rolling anything else. Notation for complementary events. We see it as, instead of probability of A, it's probability of A prime. You see it as probability, and almost like a little squiggle, and then the A. That'd be two different ways to write the complement. All right, you'll see it written both ways. I don't think we just stick with one. I think we use both. So you know both are ways to write the complement of an event. So if we're looking at this, the pictures aren't on your paper, so you just need to pay attention to this. Example, probably spinning a yellow. Well, there's 1, 2, 3, 4 colors. One of them's yellow, so probability of yellow is 1 out of 4. Which means the complement is anything that's not yellow. It would be blue, red, or green. So it would be 3 out of 4. If you want to double check your answer, add the two of them together. If you don't get one, you did something wrong and you go back and look at it. So, example, the probability of rolling an even number on a die. Well, on a die there's 1, 2, 3, 4, 5, and 6. 3 of them are odd, or excuse me, 3 of them are even. So 3 out of 6, which is equal to 1/2. You need to reduce your fractions. Right? We always reduce our fractions. So the probability of not even, the only outcomes we have then are odd. Well, there's 3 out of 6 of those as well. It also equals 1/2. Let's keep going. A glass jar contains 6 red, 5 green, 8 blue, and 3 yellow marbles. Right? We want to know the probability of picking a yellow. Well, to do that, we need to know the total number of marbles. 6 plus 5 plus 8 plus 3 should give us 22 total marbles. So if I want the probability of picking a yellow, how many yellows over the total? So 3 out of 22. Then probability of not picking a yellow, probability of picking the complement of yellow. Anything but yellow would work. Red would work, green would work, blue would work. Any of them work. So 1 minus 3 over 22. We get 19 over 22. That would be our complement. Pretty simple. A complement is just whatever we want to happen, the opposite of that. So we said probably picking yellow. Complement would be anything but yellow. Alright, moving along. Compound events. Compound event is made up of 2 or more events that can happen either at the same time or one after the other. Right, we'll talk about both, but it could happen at the same time or one after the other. Talking about compound events, there are independent and dependent events. Independent events are one that does not affect another event. Dependent events then are obviously ones that affect the other event. One event is dependent on the other one. Some examples of compound events could include rolling a dice and tossing a penny. Spinning a spinner and drawing a card. That and, that's that key word. It's telling us it's a compound event. We're doing more than one thing to find our probability. So if we look at some examples of independent events, when the outcome does not affect the outcome of the second event. So the first event is not dependent on the second event. What's going to happen is we're going to take 2 events, we're going to multiply their probabilities together. So, probability of rolling an even number and spinning an odd. Well, the probability of rolling an even number is going to be 3 out of 6 times, if we look at our spinner up here, spinning an odd has 1, 2, 3, 4, 5, 6, 7, and 8. So, 1 through 8, 4 out of the 8 are going to be odd, so it's going to be 4 out of 8. Now, if you want to reduce them before you multiply, you can, or you can reduce them after, it doesn't matter. We get 12 out of 48, which reduces down to 1/4. Now, if you had reduced beforehand, you get the same answer. 1/2 times 1/2 is going to equal 1/4. Remember, when we're multiplying fractions, we multiply tops, multiply bottoms. So, reduce either after or before, doesn't matter. Let's look at another example. Picking a jack and flipping tails. Right? That comma is just like an and. Anytime we see and or that comma, we're going to multiply. So those are the key factors we're looking for. And or the comma. So probability of picking a jack. Well, there's 4 jacks out of 52 cards in a standard deck. And flipping a tail, so times 1/2. So 4 out of 52 times 1/2. We're going to get 4 out of 104, which we can reduce down to 1 out of 26. Now you can reduce it again before you start. You get 1 over 13 times 1/2. We still get 1 over 26. Right? Like I said, either reduce before or after, it doesn't really matter. Should get the same answer either way. So those are independent events. Some dependent events. Dependent events, when the outcome of one event does affect the other event. So, an example, we choose a marble at random from a bag containing 3 blue, 5 red, and 2 green marbles. We do not, I repeat, do not replace the marble before we choose again. We make it a dependent event. So if I want to know, probably I'm thinking of blue and then a green. I'm going to multiply again, right? That comma. So probably picking a blue. Well, my total, I have 10 marbles. 3 of them are blue, so 3 out of 10. Times, after I pick the first one, I only have 9 left in the bag. I'm not putting that first one back in. So I have 2 green out of 9. So 3 times 2 is 6 over 90, which we can reduce down to 1 over 15. Right? Multiply tops, multiply bottoms. So these are dependent events. That second one, that probably changes because it's dependent on the first one. It's dependent on not replacing the marble. Try another one. Probability of picking a red and then another red. Well, I have 5 red to start with out of 10. Times another red. Well, we said I pick one, I'm left with 9. Right? I didn't put it back in. Now, I picked a red out the first time, which means my total red in the bag went from 5 down to 4. So I'm left with 5 times 4 is 20 over 90 equals 2 over 9. Pretty simple. Our last example here, probability of green and then a yellow. Well, we know, like you said, there's 10 total. There's 2 green times yellow. So, over 9. I go back up here and look, how many yellow do I have? I don't have any yellow in there, so I put a 0, right? There's absolutely 0 chance I'm going to pick a yellow. 2 times 0 is 0 over 90. Well, just going to equal a big fat 0. Right? There's no possible chance that I'm ever going to pick a yellow. So it'll never happen that I pick green and then a yellow. Pretty easy. Alright, keep moving on. Mutually exclusive events. Events that cannot occur at the same time are called mutually exclusive. So, rolling a 2 or a 4. So I can't roll a die and get a 2 and I can't get a 4 at the same time. These are events that happen but cannot happen at the same time. So I can't pick all sorts of kings together. I can't I can't roll a 2 and a 4. I can't roll a 1 and a 6. I can't roll those at the same time because it's on the same die. So what's going to happen is, we see one event, we add the probabilities together. You see this word or, right? Our keyword before was and in the comma, told us to multiply. Or is going to tell us to add. So, I want to know the probability of rolling a 2 or a 4. Well, there's 6 sides to the die, 1 through 6. So probability of rolling a 2 is 1 out of 6. Plus, probability of rolling a 4, 1 out of 6. Remember, when we're adding fractions, we need a like denominator, and it stays the same. We add the tops. 1 plus 1 is 2. So, reduce it down to 1/3. Alright, let's try another one. Probability of picking a king. Well, there's a king in each suit, and there's 4 suits. So there's 1 king of diamonds. So 1 out of 52, plus there's a king of hearts, plus there's a king of spades, plus there's a king of clubs. So it's all going to equal 4 over 52. 1 plus 1 plus 1 plus 1, which equals 1 over 13. Now, if you can go right to saying, hey, I know there's 4 kings out of 52 cards, boom, go right to the end. You don't have to do that whole step. right? That's just showing us that there's these 4 events that cannot happen at the same time. I can't pick a king of clubs and a king of diamonds if I'm picking one card at once. So, ends up being 1 out of 13. Next one, picking diamonds or hearts. Well, how many diamonds are there? Well, there's 4 suits, 52 cards. There's 13 of each suit in the deck. So 13 out of 52. There's 13 diamonds plus hearts. There's 13 of those out of 52. So I'm going to add them together, right? My denominator stays the same. 26 out of 52, which reduces to 1/2. So probably I pick a diamond or a heart is 1/2. Alright, last one here. Probably I'm picking an ace or a club. Right? That or tells me I'm adding again. So there's 4 aces out of 52. Plus, there's 13 clubs out of 52. Now, we have to be careful here. We're also going to have to subtract 1 over 52. Because there's an ace of clubs that we counted in both the aces and in the clubs. And we can't double count it because there's not 2 of them in there. Right? That's throw off our probability. So I know I'm counting in both aces and clubs, so I got to subtract 1 off, otherwise I'm double counting the ace of clubs. So what I can do is I can add them up here. 4 plus 13 is 17, minus 1 is 16 out of 52. And that reduces down to 4 out of 13. Awesome. So last thing, you flip it over, there's a couple sentences on top. Just a reminder, if you see and or a comma, you will multiply the probabilities together. If you see or, you will add the probabilities together. Right? A lot of this stuff should be a review. You should have seen some of this already in algebra and geometry, so it should be a good amount of review. If you're still struggling with it, go back and watch the video again. Ask your friends for help, right? Some people are going to get it, some aren't, so help each other out. And then work on the homework. Have fun.